All right, so functions can also be represented by equations. Sometimes we call them rules. All right, and then the graph of an equation, which is all of the ordered pairs that could come out of that equation, often forms a line or a curve. Okay. A lot of times we use the analogy of a machine to talk about a function. So we put values in, those are x values. The x value is called the independent variable because we are picking. Okay. So I can tell it, let's put in 2. It goes through the rule and it comes out with a y value, so we call that the dependent variable. Right. So one thing that we can do is then we can use these rules to create a table and graph functions. Okay, so here's the rule I have, y equals x plus 4, and we're going to graph these x values. So what I'm going to do is I'm going to take each value, I'm going to plug it in for x in my equation, and then I'm going to solve. Okay, so for this one, I would have y equals -5 plus 4. That would give me -1. All right, then I would have y equals -4 plus 4, and that would be 0. All right, y equals -2 plus 4, which would be 2, and then y equals 0 plus 4, which would give me 4. And then I can graph each of these ordered pairs. So -5, -1. Okay, then -4, 0, -2, 2, right? And then finally 0, 4. Okay, and then if I connect those dots, that would give me the graph. So this is another way to graph. We learned how to graph with slope-intercept form before. Now we're seeing how we can graph with a table. Okay, and then the cool part is, because it's 2025, we can also use Desmos to help us create these tables. All right, so here I have my Desmos window, and we're going to use it to do number 2. Okay, so I'm going to click this plus sign and add a table. Okay, and notice Desmos says x1 and y1. Now I have to give Desmos the rule. So I'm going to type my equation in, but instead of just y and x, I'm going to type y1 and x1 so that Desmos knows I want it to put it in the table. So if I just type y1, it automatically pops it down into that little subscript. I don't have to do anything special. So y1 equals 3/4, and then I'm going to do x1 and then -2. So all I did was type this equation in with y1 and x1 instead of just y and x. Okay, then in my x1 in my table, I can go and put in the numbers that are given to me. So I can put -4, 0, 4, and 8, and then Desmos will give me the y values. So it's a little bit faster than me trying to multiply fractions in my head or do each individual piece of math. Okay, so that means these values would be -5, -2, let me bring that back, 1 and 4. All right, 1 and 4. And then I could go ahead and graph those points, or at least the ones that fit on the graph. I skipped 8, 4 because it doesn't fit. Okay, and then I have my graph. Okay, so I want you to pause and you are going to try number 4. All right, so you can see over here that I put the table in and put my equation into Desmos. I got my y values and then I graphed them and connected the dots to finish it off. All right, and here we have like a different way of writing the same thing. Okay, remember domain is x values. So these are all x's that I would plug in. So I would have y equals 4 minus 5, y equals 6 minus 5, and then y equals 8 minus 5. All right, so 4 minus 5 would give me -1. 6 minus 5 would give me +1. 8 minus 5 would give me +3. So my range would be negative 1, 1, 3. I'm going to draw my bracket. Okay. You could also use Desmos here. This would be your rule. So I would put y1 equals x1 minus 5, and then I would put these values in the table and get the y values. All right, now where this gets a little tricky is when we talk about something called function notation. So you're used to seeing equations written like this. We can also write them like this. F of x equals 4x minus 1. So instead of y equals, we usually say f of x. It could be g. It could be a different letter, but we put the s or the f in parentheses. So this is read as f of x. Okay. And in this case, x is the domain. All right. And then f of x is the range. Okay. I like to think of it as this is the name of the function. So we're just calling it function f. All right. And then this is the value that we are plugging into the function. So when we write it generally, we just say x. But as you can see down here, we can write it with specific numbers. So f of negative 7 means, if you notice, here it's f of x, here it's f of negative 7. That means plug negative 7 in for x. All right, so I would have f of negative 7 is going to be equal to 4 times, instead of x, it's going to be negative 7 because I'm plugging that number in, minus 1. So f of negative 7 is equal to, this would be negative 28 minus 1, so negative 29. All right, so this is a different notation, a different way of writing plug negative 7 in for x. All right, so let's do another example here. I want f of 5, okay? So f of 5 means I'm going to replace the x with a 5. All right, so that means f of 5 is equal to 12. Okay. One thing I want to point out, it's really important to use parentheses. So let's look at number 4 as an example of why. So I want f of negative 4. So f of negative 4 equals, I'm going to put negative 4 in parentheses, okay? And then minus negative 4 again in parentheses. The reason I do that is if you put this in your calculator and this in your calculator, you will get two different answers. All right, this in your calculator will give you negative 16. This will give you positive 16. The reason is your calculator does order of operations. So it does the squaring part first. So 4 squared is 16, and then it puts a negative sign in front of it. But what we want is the number negative 4 squared. And negative 4 times negative 4 is positive 16. So make sure when you're writing this down and when you're putting it in Desmos or your calculator that you are using parentheses. Okay, so f of negative 4, all right, is equal to 16, and then minus negative is the same thing as plus, so that means it is equal to 20. The other thing that we can do with functions is we can plug in, instead of just a number, we can plug in a whole expression. Okay, so what does that look like? F of c plus 7. All right, all that means is where the x is, instead of plugging in a number, I'm going to plug in this whole thing. So I'm going to have 4 parentheses c plus 7 plus 11. So I replaced the x with this. I took this and put it where the x is. Okay, and now we're going to simplify this expression. So I'm going to distribute that 4. So I would have 4c plus 28 plus 11. And then these are like terms that I can combine. So that would be 4c plus 39. Okay, I'm not solving anything. I'm just substituting that in and then simplifying as much as I can. All right, then the last thing you need to be able to do is to evaluate given a graph. Okay, so here I have f of negative 3. Remember, that means I'm plugging negative 3 in for x. So that means on my graph, I am going to go to, and I made this a little bit bigger so we can see better. So I'm going to go to negative 3 on the x, and then I'm going to see where is my graph at negative 3. So that point right there is negative 3, 2. So that means f of negative 3 is equal to 2. All right? And I can do that for any value. So f of 1 means go to positive 1 and then see where the graph is. It is also at 2, so f of 1 is equal to 2. Okay? F of 0, 0 is right here, so my graph is all the way up there at 1, 2, 3, 4, 5. So f of 0 is equal to 5. All right, then we have f of 2, so 1, 2. Where's my graph? I think it's like right here, looks like. So that would be negative 1, 2, 3. So f of 2 is equal to negative 3. All right, so this time it's not the equation, but we're using the graph to figure out what y is at these specific x values.